Good afternoon, everyone. And first of all, I am Bonil Shah, and I have done my master from DAIICT, which is in Gandhinagar, India. And let me thank all the panel members for accepting my paper. So, the title of my paper is Performance Study of Time Series Databases. So, in this paper, I have compared different types of time series database on different kind of parameters. So let's see them one by one. So let's go through the abstract part. So like we all know nowadays, the popularity of IoT device is increasing. So with an IoT device generates a large amount of time series data. So along with the popularity of IoT devices, the popularity of time series database is also increased. And there are many different vendors available in the market for time series database. So it is difficult task for us to choose the best one from them. And there are some benchmarks also available, which compare the time series database, but all they are using is some random or synthetic data set. Means they are not using any real data set. So it is required to compare the performance of time series database with the real data set. So which I have done in this experiment. And the most significant elements to consider while comparing is performance. So I have divided the performance in two parts. The first one is queries and second one is storage. So talking about queries, so we will compare the database by executing different kind of queries to all of them to see like which database took less time to execute this query. And the second thing is storage. So storage is also storage is also a good factor to consider, because like we want to see like how much space it takes to store the data. So before going to the experiment, let me tell you what is time series data. So time series is an ordered sequence of values of a variable at some specific time interval. That means, as you can see, like at this particular time, the value of this variable is this. So this data is optimized for measuring change over time. And some big organizations like Facebook and eBay are using time series database rather than some relational database for data operations. So this is the popularity trend graph provided by dbengines.com. So from July 2017, as you can see, the popularity of time series database is increases the most. This purple line shows the time series database, and these are the other database. So as you can see, the popularity is increases the most of time series database. And these are some core property of time series database. The first one is it has fast and easy range queries. So you can query anything from the data, and you can get you get the desired value. The second is high write performance. So the time series, most of the time series database are NoSQL database, so it has very high write performance. The third one is data compression. So it is the most required properties, because like many of the IoT sensors produce like many of the IoT sensors store every 1 second data of the element. So the data could be very large. So data compression is required. The fourth one is scalability. So time series database can handle very large amount of data. And yeah, these three are the use cases of time series database. The first one is time series analysis. So which means we can analyze the variable which changes over time. So the examples are like we can analyze the temperature of some particular country, or analyze the water level in some river or something like that. The second point is time series forecasting. So which means we can predict the future activity by using the historical values. Like the example of time series forecasting are like weather forecasting or earthquake forecasting, etc. The third point is regression analysis, means how the changes of any one variable affect the other variable. And the example is like like how the changes of one stock value affect the other stocks in the market. So we can analyze these as well using time series database. So after hearing this, like all of us have one question in mind, like can why have to use time series database? Can we also use some relational database to handle the time series data? So the answer is yes, you can use relational databases to handle time series data, but these two are the main points you have considered. Like these two are the main points, two are the reasons why we have to use a time series database. So the first one is scale. Like as I have said, the time series data accumulates very quickly. So some like all the traditional databases are not designed to handle huge data set, but time series databases can handle the huge data set. The second point is usability. So many time series database include built-in functions like data retention policies, continuous queries, and flexible time aggregation. Like we can use this function to like supply like for how much time you want to store the data into database and how many copy you want to store. So the life will become easy by using time series database. So as I have said, there are many benchmarks available in the market. So let's see two or three of them. So the first one is IoT benchmark. So it is built exclusively for time series database and IoT application scenarios. And it this benchmark have four different performance metrics like query latency, space consumption, system resource consumption, and throughput. The third point is, as I have said, all these benchmark are using randomly generated data set, and this IoT benchmark has 10 different kind of queries. So they perform 10 different kind of query to compare all the database. And currently they have support for IoTDB, InfluxDB, CuriosDB, and etc. These all are the time series databases. And the main drawback of IoT benchmark is it mainly focuses on IoTDB. Okay, the second benchmark I have studied is TSDB bench. So it is the oldest benchmark available there for time series database, and it enhances the Yahoo Cloud Service benchmark, which is called as YCSB, for use with time series databases. So as I have said, this is the oldest benchmark. So the documentation is outdated, and the actually the domain is also not working now, and the databases version used in this benchmark is also very old. So and this benchmark only have two performance metrics like query latency and space consumption. The third benchmark I have studied is TS benchmark. So it is the latest benchmark. The paper published on this in 2020. So it is basically centered on requirements of managing huge time series data. So the different thing about TS benchmark is it uses DC GAN based model to generate high quality synthesized data. So they have used some wind farm data to generate synthetic data using a DC GAN based model. And they have considered different workload like data injection, data loading, and data fetching. And they have used six different kind of queries to compare all the database, and they have currently support these four types of time series database: InfluxDB, Druid, TimescaleDB, and OpenTSDB. So in my experience, experiment, I have used these four databases. The first one is TimescaleDB. It is a time series database which is totally based on Postgres SQL. So it has all the features of Postgres. Second one is Druid. It is also a open source time series database. The third one is InfluxDB. So it is the most used time series database in the industry. And the fourth database I took is Cassandra. So Cassandra is not a time series database. It is a NoSQL database. But I have pick it to like see the result, like how this database perform on time series data. Okay, so all the existing benchmark perform the experiment with synthetic data set, but I have used all real data set for from different kind of domain. So first I have to the financial domain, and the data set I have used is already published on Kaggle. So it is data set. It is the data set about uh, 1 minute data set for 150 NSE stocks. So it from 2017. So it has the data of stock value from 2017 of 150 stocks. And there are 7 different fields on this data set: the stock name, timestamp, opening price, highest price, lowest price, and closing price. The second data set I have used is from analytics domain. So this data set is also available on Kaggle. And this is the data set about yellow taxi data of the month of January 2015. So the fields of this data set are vendor ID, pickup date time, drop off time, passenger count, trip distance, payment type, etc. The third real data set I have used is from IoT domain. So this data set is I have took from Chicago data portal, and this data is about uh, 14 different lakes which are in Chicago. So the fields of this data set are beach name, measurement timestamp, water temperature, turbidity, wave height, wave period, battery life, etc. And along with these three real data set, I have also picked one synthetic data set to use time series generator library, which is available in Python to generate random time series data. And this data set is about some fast food item sales in different countries. And you can see the name of the fields here. Okay, so after picking databases and data set, so it is time to decide which queries I have to pick. So the existing benchmark have used some random queries to compare the performance, but I tried to use like all the kind of query to compare the performance. So like I took exact point query and all kind of aggregation query like mean, max, sum, average, count, and I have also picked a time range query and group by query as well. So I have picked total 8 kind of queries. And talking about performance metrics, so I have compared the performance based on these three performance metrics. The first one is throughput, which is used to measure data loading performance of individual databases. That means how much time the database takes to store the particular data. The second one is space consumption, which means which measures the space used to store a particular data set for every database, like how much space does some database required to store some particular data. The third one is query latency, which measures the time required to run the particular query for different databases. Okay, so these are the results of the first our first matrix, data loading or through you can say. So in this column, you can see the different database: TimescaleDB, Druid, InfluxDB, Cassandra, and this row, you can see different data sets. So this is data set of IoT domain, this is the financial domain, analytics domain, and this is the synthetic data. So these number represent the time required to store the particular data set in seconds. Like suppose TimescaleDB takes 8 seconds to store IoT data set. Likewise. So as from the table, we can see that InfluxDB has the best performance among all of them. Like it stores the data very fast, and after InfluxDB, Druid is the best performer, as you can see. But the interesting thing to notice here is Druid is the second best performer in all real data sets. But it is the worst performer in synthetic data set. So you can see the difference here between real data set and synthetic data set. So this is the performance matrix of space consumption. So this first row represent the original size of the data set in MB. So IoT data set is about 4 MB, financial data set is about 4 GB likewise. So in space consumption, as you can see, Druid is the best choice. Like it takes uh, very much less space compared to all other databases. Like like in financial data set, uh, the original size is about 4 GB, but Druid only takes around 1 GB to store that data. So we can say that Druid compresses the data in very high manner. So this is the most important thing in time series data. Okay, so these are the graphs about query latency. The first one is exact point query. So as you can see, Druid is the best performer in IoT and financial data set. And after that, InfluxDB. In all the case, Cassandra is the worst performer. As I have said, it is not a time series data. So yeah, this is the chart about aggregation query. Like this is the chart about some aggregation query. So as you can see in this graph, uh, Druid is the best, like InfluxDB is based in synthetic and analytics and IoT, but uh, Druid is based in financial data set, because like the reason is financial data set is very big, and as I have said, Druid compresses it well, so it takes less time to query the data. And the interesting thing to notice here is TimesKDB takes like lot of time, like it is higher than the Cassandra. So so the reason is as I have said, TimesKDB is completely depend on Postgres. So it stores the data in row or column format or in table format. So it takes lot of space, and to query that data, it takes lot of time. So this is the similar result we have seen in group by query and time range query also. The Druid is the best performer in most of the cases. So in conclusion, I would like to say that this I would like to give some. So if your focus lies on load performance, like you want to load the data very fast, so InfluxDB is the best choice. And the second point is, if your focus lies on lowest space consumption, like if you want to store data in very, like you if you you want to store data in very less size, so you can choose Druid. It is the best choice, and InfluxDB is the second best choice after Druid. And talking about queries, so if there are more aggregate queries you have, then you can use InfluxDB. So it performs very well on all kind of aggregate queries like sum, mean, max, or average. And if there are queries containing data filters, like if your query has time range or a group by query, so Druid is the best choice. So talking about some future works. So in this experiment, I have used only 4 databases: InfluxDB, Druid, TimescareDB, and Cassandra. But more can be added further, and we can also add relational database and non-relational database as well. And the second point is, the query workload could be extended to include data mutations such as create, update, or delete queries. So currently, I have only experiment on select query. Or I have used all the select query. So experiment can be done using this data mutations query as well. And benchmarking using this query workload might produce even more accurate results. And the third point is, in production environment, time series databases are often used in multi-node setups. And I have done the experiment in single node setup. So multi-node setup experiments can be done also. Yeah, these are the references I have gone through, and thank you so much for listening.